Welcome back to the classroom. I am Mr. Wong, and today we'll be looking at the 2021 Independent Physics paper, question 19. This is going to cover Module 2, Inquiry question number 2 as well. The diagram shows a man pulling on a rope with a force of 60 newtons to move a 12 kg box across a rough surface, as you can see here. So rough surface obviously implies that there is friction. So we might need to look at that later on. As a result of this force, the box slides across the surface with an acceleration of 3 meters per second squared. So that's the acceleration. The question is, what is the net force on the box? Okay, so the net force on the box, we can work it out in two ways. We have the acceleration, we have the mass. So obviously it's being accelerated in this direction, so we only need to use F equals ma. So F net is equal to 12 times 3, and that would give us an answer of 36 newtons moving in the right hand direction. So that's what we have there. We could also prove it using this force components here. So if we have a look, actually let's skip that for a second because we can't do that because we're not accounting for friction. So that's how you work it out. That's reasonably straightforward. Question B, it says determine the kinetic coefficient of friction on the surface. So this is where we use our net force, and we use the force component that we have here with friction to work out. So we have our net force. We also have the force of the X component pulling on the rope plus the force of friction. We're going to find the coefficient because we know that the coefficient is F normal added on like so. Okay, so let's have a look. So we have a net force of 36. The component that we have is 60. This component here would be 60 cos 40. So 60 cos 40, and that is our friction force there. So our friction force is the subtraction of 36 subtracted by cos 40. Okay. So if I do that value in, or if I plug that value into my calculator, we get approximately negative 9.962666587 newtons. We'll just leave it as this number here for now. We can round it, but you know, so if we round it to 3 sig figs, that's the value we have. So I'll use this in my working out, but I am going to use the complete value in the actual calculations. Okay, so I'll just say that again. I'm going to use this value just for ease to write in this calculation, but I'm going to use the final value or the full value when I'm doing the actual calculation part. Oops, just go back on that. Okay, so we have the friction force, we have the kinetic coefficient, that's what we want to find, and now we need to find what the normal force is. If we have a look, the normal force is comprised of a couple of components. Okay, now under normal circumstances, the normal force is equal to the gravitational force. Okay, but what we have here is the normal force is coming down here, or the gravitational force is coming down here, and we also have a force pulling upwards. So we have two opposing direction of forces. Okay, so what that actually means is we subtract by the fy component. This is our fy component here. Okay, so that's what we have. Okay, we could, write it as, or actually we'll just leave it as it is there. So let's show for it here, negative 9 or negative 9.96 equals to UK multiplied by 12 times 10, 9.8 plus it was 60 sine 40. Okay, or whoops, subtract by. Okay, so if I change that number now, this is the value we have. Okay, so the value we have is 79.0324, 74342. We'll have that as a positive value because we are just trying to find the magnitude of the friction force, so it kind of ties everything in nicely here. The only way we could use this as a negative value is if we assume that G was also negative, but since we're just trying to find the magnitude, that's okay. So now we rearrange mu K is equal to, we'll use the number on top here, so 9.962666 over 79.03274342. You can sort of see why I would have preferred to use it as, or write the numbers in 3 sig figs. Wouldn't really change the number overall, but let's have a look at what we get. So our coefficient, or our kinetic coefficient of friction, is the following value here. And if we round off to 3 sig figs, it'd be 0.126. And that's how you solve the problem there. If you found this explanation useful in your understanding of solving for such problems, hit the like and subscribe button, and I will see you next time.